Just a little bit about me before I get into the conversation here. So, as you heard, my primary scientific specialty is with things that have to do with water, a lot of wetlands work, wetland ecology, but I also feel very privileged that even though I work at a secular university in a geology program, half of what I do on the research realm is actually related to faith and science. And I get to put that on my activity reports every year. So these were some of the books that you just heard mentioned. And I want you all to take a picture of this. And if you want, you can actually pull up the paper with that QR code, because that just came out yesterday. It is an open source paper. It is not behind a firewall. And it is related to, as you see there, the title Inerrancy and Navigating Bible Science Tensions. So I'm pretty excited that that has just come out. Oh, and just for fun, I also, just as a hobby, do science fiction. So if anybody's curious, you can hop on greggdavidson.com, Gregg with 2 G's, and you'll see some of this science fiction work, all of which has an underlying Christian worldview in the themes. All right, we live in a time of ever-increasing polarization, which in the world is understandable. If we have those that are trying to follow Christ, those who are against Christ, we expect some of that polarization. But when it comes to things like origins, we also see that polarization happening in the church. So we have a lot of divisions, which was part of what I was at ETS, at the meeting. We're like debating some of these things that are causing these divisions. And we have organizations that have sprouted up where, to just illustrate some of that polarization, the ones on the left are arguing for a young Earth viewpoint, the ones on the right more from an old Earth and life-adapting viewpoint. They all claim to be Christian, all claim to believe the Bible is true, all believe that the other side is misinterpreting both science and Scripture. So you get to be introduced to some of that today if you haven't already. And what I'm going to do, this is going to be a little bit experimental. This talk has been fashioned, as it were, just for you all, where I'm going to present some background information, and then where we go from there is going to depend on some questions and how you answer them. So it's just sort of like those computer games where where it goes depends on the path you choose, right? Or the stories, right? The books where depending on which direction you go, the story's different. All right. So both sides of these arguments claim to be on this side that are using the biblical lens to view the earth, the other side that is using a secular lens. Ironically, there's even that charge that's made against the young earth community that they're not actually looking at things with a biblical lens, but with a 21st century Western scientific lens without realizing it. All right, so when it comes to creation and the flood, the background that I want to give you first is just what is the position of conventional science, and Christians that would ascribe to that conventional science, versus what a young earth or flood argument would be for the history of the earth. So the conventional model, we've got 2 slides here. Earth history characterized by both slow and rapid processes, so not just slow, because everybody knows that things like volcanic eruptions occur that are very fast, but that they operate under constant laws of physics and chemistry. Catastrophic events have occurred in Earth's history, but distributed through time and space, not just one event at one time. That radiometric dating yields reliable ages up to 4.5 billion years for the Earth. Plate tectonics, the movement of the Earth's crust, has resulted in plates moving apart, colliding, so that land masses rise and fall, so that sea levels at times are over the tops of part of continents and part below, so you get alternating times of marine and terrestrial deposits. And that the fossil record represents changing life over vast time. So, little cartoon illustration of that, where we have the oldest layers at the bottom, all these geologic names, moving up to the top with us up here in the present. Alternatively, the flood model or young Earth model is that the majority of the Earth's layers are characterized by a massive, catastrophic global event, that radiometric dates are unreliable, that plate tectonics in the distant past was fast, forming mountains and trenches, arguably in a matter of days, that the Earth's ruptured crust released subterranean water, caused mega tsunamis sweeping over continents, resulting in the majority of fossils buried in 1 year by a flood. Now, interestingly, that community does not challenge the general scientific understanding of the order of the layers or of the names given to them, but simply challenge the timing, duration, and cause. Right? So, young Earth community does not disagree with any of these names or the order or even the fossil sequence that is seen there. But instead of all of these years and millions of years, they divide it up where there's not complete agreement among all within the young Earth community, but the most common arguments place these Paleozoic, Mesozoic, and Cenozoic eons into the early flood, late flood, and then post-flood. All right, so here's where we start getting interactive. We're going to start with the Bible, and then we're going to move into science. So if you are presented with the options that I've just given you, and you don't just have a knee-jerk reaction of, oh, one's right and the other's wrong, right? You step back and you say, okay, I want to actually make sure that I not just believe the Bible's true, but that I interpret it rightly, right? Because the Bible's true, but our interpretation is not always true, not even always inerrant, right? Interpretation's fallible. So if I just say, I want to know what should I be looking for in Scripture to determine whether, say, the Genesis account of creation or the flood story, whether it is intended to be a straightforward journalistic account, or if it might be an inspired, inerrant, literary account that's not intended to be read journalistically, right? What would you look for? And by the way, I understand that most of the people here are undergraduates with a few more seasoned folks from out and beyond. I'd like to give the undergrads first stab at answering some of these, but if there's a prolonged silence, then others can feel free to chime in. So what would you look for to answer that basic question? We're making eye contact here. What do you think? Terms that describe time periods. Yeah, so we do have the 7 days and evening, morning, so you have at least that reference to the passage of time, though like the simplest, superficial reading would just be 7 24-hour days, right? What else might we look for? Yeah, just go ahead and speak up if you're... Oh, over here. Okay, yes.
You might look for the style of writing, whether it's which kind of sphere.
Yeah, you definitely look at... So the suggestion was that you look at the style of writing. Another word for that is genre. So is this just a historical narrative? Is it poetic? Is it some other form that would suggest to us that it was not intended to be just read in this journalistic fashion? So we'll look at that in just a moment. One of the other things we might look at would be, are there internal inconsistencies that would be forced if we read it in that journalistic fashion? So we could spend like the entire time just looking at this question. So I'm not going to spend a lot of time on this. I'm just going to kind of note that if we're just reading it as 7 straight days, there are some issues that seem to pop up that at the very least make us take a deeper look. Things like the order of creation in Genesis 1 and 2 are not the same. Light's actually separated from dark twice. It's separated in day 1. It's separated again in day 4. Separation of light and dark itself is a little bit enigmatic, because if I gave you a jar of beans and I said, I want you to make a pile of beans on this side, the left side of the table, and on the right side of the table, I want you to make a pile of the absence of beans. What would you think about that task? Here, and some of you are like, what does this have to do with light and dark? Dark is just the absence of light, right? Dark is not a substance that can be independently isolated. Okay, tremendous theological significance there, but physically? Sky is described as a solid surface. First 3 days, evening and morning, with no sun? You don't have evening and morning unless you have a globe with a fixed light source from a fixed observation point that will rotate in and out of that light. And, of course, it ends with a day of rest that God doesn't need. So, diving a little deeper into genre. So, one of the things that I find fascinating are the use of the number 7, where that's the biblical number of fullness or perfection. And when you start to see how often it is used in Genesis 1, it's jaw-dropping. Like the very first verse in Hebrew, 7 Hebrew words. Second verse, 14 Hebrew words. The number of times all these phrases are used, all multiples of 7. Then you have the start of the story with rhyming words, tohu and bohu, which are variously translated as formless and empty, followed by 3 days of solving the formless problem and 3 parallel days of solving the empty problem. Parallelism is a big deal in Hebrew poetry. That seems to be even emphasized more by the fact that it uses these triads of God said, there was, and it was good, that gets repeated twice in day 3 and day 6, seeming to emphasize day 3 is the culmination of solving the formless problem, day 6 culminating solving the empty problem. But there's one little hitch to that argument. Do you guys see any problem with that parallel structure? Should pop out to you here. It's got holes in it. If this was intentional, why would God have inspired that? I mean, is that just like, yeah, okay, I get what you were headed at, but it doesn't really work, right? Big question marks there. Okay, check this out. Suppose I gave you the task. I want you to use the phrase, it was good, or just the word good, 7 times in the creation story. Distribute the word good. How would you do it? You have to think very long? Gee, I got 7 days and 7 uses of a word. I think I'll put 1 in each day. The author doesn't do that. Day 3 and day 6, wanting to emphasize those as the culmination of solving the formless problem and the empty problem, good gets used twice in each of those days. That takes up 4 of our 7. We have 3 left. We have 4 days to fill. What are we going to do? Well, we have to pick a day where it gets left out. That's day 2. So we'll go over to the parallel day 5 and leave out a phrase there. That is actually known as elliptical parallelism in Hebrew poetry. Now, I have to say, I had to say this at ETS yesterday, where there's a bunch of Hebrew scholars, because the first thought that they have is every Hebrew scholar knows that Genesis 1 is not classical Hebrew poetry. And they're right. But that doesn't mean that it doesn't have poetic elements distributed all through it. And my argument is that the first of all songs has the right to use poetic elements as it sees fit. Parallelism is a big deal in Hebrew poetry. That is absolutely parallel structure. So, what does that do? Does that tell me that the creation story is not history? Not at all. I do believe that this is history, but the question is it a history that is read journalistically, or, as we started out this conversation, is it to be read as inspired, inerrant, literary history, where it is capturing aspects of the culture and their appreciation of poetic structure and the storytelling, which says it to me that it's history, but it cautions me against being overly literalistic in my reading. All right, so going from there, I then see passages like this. So Genesis 1 has 2 verses that say that God's told the earth to bring forth plants and then animals. So notice there's only one time where God calls something to exist from nothing, and that's the very, very beginning. Everything after that is being fashioned from what has already been called into existence. So he's calling the earth to produce plants and calling the earth to produce animals. Well, given my reading of Genesis, where I'm seeing all these poetic elements, I have this caution against over-literalistic reading. I had those potential problems that we started with if we force a literalistic reading. This at least says to me that I have the possibility of satisfying this verse, or that the earth obeyed God's command. Could have been in a single day, or it could have been through a succession of generations, where the earth is being obedient and bringing forth life. All right, when it comes to the flood, there is no question that the wording of the flood is what we call universal. Right? It talks about all of the earth being covered with water. But we don't read Scripture in isolation. Reading it in the larger context, we realize that we also have verses that are saying things like, all the people of the earth came to Egypt to buy grain. It says there was a famine in all the earth. That Nebuchadnezzar was said to be the king of all the nations of all the earth. And fast forward to Jesus, Satan takes Jesus up to a very tall mountain where he can see all the kingdoms of all the earth to be tempted to rule them. Well, we know that Nebuchadnezzar was not king over nations in China. We know that it doesn't matter how high you get lifted up, you cannot see the backside of the earth, right? You can't see the opposite side of a globe, no matter how high. From a satellite, right? A stationary satellite in the sky, you cannot see what's in China. Has to actually move around to the backside. So we know that the scriptures use language that is either hyperbolic or is simply referring to that known landscape. So that again, at least opens the door to considering the possibility of Noah's flood, which again, I believe is history, but it either being a global phenomenon or it might have been something that was very large scale, but not necessarily global. A new book that just came out by Hugh Ross, that was one of the speakers yesterday, was advocating for the latter, where it was covering all of humanity at the time, which had not yet migrated into distant lands. All right, so science. So we also want to understand this rightly. So we have 2 competing models that I described to you, right? I described what is the conventional model, what is the young Earth or flood model. So just as a reminder, right, we've got long ages of rising and falling sea levels, alternating terrestrial and marine. Terrestrial means on land, right? Marine's in the ocean. Flood model, it's all happening basically in the span of 1 year. Tsunamis careening over the landscape. What kind of things are we going to look for? And from here, I've got a bunch of slides that, like, if I walked through them, we'd be here a while. So I'm not planning on going through all those slides. I want to know which ones you think we should go through. So what kinds of things would you look at in order to test these competing models?
Archaeological evidence, some people believe be really old, or actually for the early flood, there should be human remains there too.
Yes, that's excellent. And of course, the very first suggestion is one that I have no slides on. Actually, I do, but not directly addressing that. But the idea of human habitation, that in the flood model, we should have some evidence of human remains through the entire sequence, right? So, of course, there is the argument that humans could, like, hang on to things, get on rafts for a time so that they might be concentrated more towards the top. But things like pottery, stoves, homes, bricks, those things would get swept. They're not floating to the surface. So we should find some evidence of human habitation at the very deepest levels. So I do have slides on that, but I'm going to hold on those because chances are there'll be some other ones that will be similar and we can look at them at the same time. Yes. Yes, you.
Assuming the layers are accurate, would there be some kind of are there any animals that were supposed to have died a long time ago that still exist?
So there's kind of two things in what you just said. So the question was, since this is getting recorded on the mic, I have to remember to try to repeat these things. So the question or suggestion was that there should be some fossil life or animal life that is going to be indicative of either this chaotic mixture of things, or for the conventional model, it should be something that is much more ordered in some kind of progressionary sequence. Is that fair? Okay. Yes.
Animal speciation.
Oh, okay. Yes, animal speciation. So the question is, could there be enough animals on the ark in order to give us everything that we see today? And that's actually, we could spend an entire time just on that question. That derives from the recognition by the young Earth community that you could not fit all of today's animal species on one ark. So they have, their position has evolved. I use that word on purpose. Where they don't have examples of every species. They've defined kind as something not even at the genre level, but as high as like family and even order, where you have like a single cat kind on the ark and a single dog kind. And after getting off the ark, you have hyperadaptation, I call it hyperevolution, to produce all the species we have today. So those are things that we could look for. All right, so I think we have enough input there. And so what I have to do here is get out and look at where some of these slides are to see what we're going to pull up first. All right, let's do this first, where this is just going to emphasize kind of one expectation, that this is Japan in 2011 with a tsunami wall. That's what this wall is. It's intended to protect against tsunamis. 2011, they failed to protect themselves from that tsunami. It came right over the top of that wall. This is an empty lot before, so this is not like scoured clean. This is an empty lot before the tsunami. This is what it looked like afterwards. And I love this illustration, this photo, because it beautifully illustrates the expectation of mixed marine and terrestrial. Right? We got houses and ships that are like all jumbled together in the same layer. So this is getting at the idea of what is our expectation of the fossil sequence. Is it orderly or is it a chaotic mixture? Some examples of all kinds of different life forms that are then mixed together. So, all right, so I'm going to do this really quickly here. So this would be the conventional understanding of life that is adapting over time. So the idea of the Earth obeying God's command and beginning to bring about life from the simplest organisms and moving onward. And this is important because there's a misunderstanding of conventional science that this process is just about simple to complex. Yes, there's an element of that, but it is so much more specific than that. There's another sense that if this adaptation of life has happened over time, that it's random, and if you rewound the clock and did it again, you'd get something completely different. And that is absolutely not true. there are very, very specific expectations if the Earth obeyed that command through this evolutionary cycle. So the fact that the screen is blank right now does not mean that there's no argument. It just means we haven't started it yet. So what we're starting with is that at the bottom, single-celled in water. That's important because water is the easiest environment in which we could have life because it's easy to get nutrients in and waste out. So what we're going to see is a stepwise move into increasingly difficult environments, as well as beginning to make adaptations to take advantage of the ability to sense things, the ability to get food, and the ability to avoid becoming food. So from single-celled, there's only one direction to go, to multi-celled. You're then getting things like locomotion, you're getting sensory organs, you're getting the ability to feed. We're going to see expect to see adaptations for acquiring food, processing food, and avoid becoming food, which can include developing hard parts like teeth and shells, at which point our expectation of fossil preservation would dramatically increase when we begin to have hard parts. From there, we would expect excursions onto land, which is a harder environment, because now you have to be able to breathe air, you have to be able to support yourself if you're a tetrapod up on 4 limbs. So amphibian-like characteristics. Next hardest would be permanent living on land, because now we have to have internal water regulation. And if we're going to have reproduction with something like eggs, they have to be able to survive out of water without desiccating. From there, that reptilian body plan could be adapted to go to the air, it could be adapted to go back to water, or to move into the next more difficult environment of cold adaptation, where we might see we've got some degree of warm-bloodedness. We could have insulating coverings that might look like fur, might look like feathers. That body plan could be then adapted for moving into air again, or back into water with both the feather and the fur side. So the point of all this is there is a very specific progression that would be anticipated if the Earth obeyed in this manner. So if we actually then look at what we find in the fossil record, in the oldest layers, we see no life at all. So below this, we get into, like in these Precambrian rocks, we're seeing just these single-celled life forms. We're then starting to see multi-tissue organisms, but they're all soft, very few preserved. Then we see our first organisms with both locomotion and hard parts. In the Cambrian, which corresponds with an incredible increase in the number of fossils that are preserved. So what you've heard of like the Cambrian explosion, it's because we have hard parts. We then start seeing things like fish with no jaws, shelled organisms, a little bit more complex fish, some scorpion-like creature here. Our first excursion onto land with tetrapods that are still partially tied to water. And then eventually we're starting to see our first creatures that can live full-time on land, reptilian features. And our first creatures that are starting to look mammalian. They're not full mammals yet, they look mammalian. Now it's interesting because what I just showed you is the Paleozoic rocks. That's what's exposed in the Grand Canyon. So everything you see in the Grand Canyon is this Paleozoic or older at the bottom. So if we're trying to test competing models, right, our expectation of a very chaotic mixture would be that we'd have a lot of the things we see today, or at least those body plans, mammals, reptiles, amphibians, mixed together. And certainly at the very bottom, what would you expect on the absolute very bottom? So if we have things sweeping over the land into the oceans, burying everything that's in the ocean, so the absolute bottom of that should be, well, yes, some evidence of human civilization, but at least things like coral reefs, eels hiding out in caves, oysters, sand dollars, lobsters, right? All of that would be at the very bottom. Not only do we not see that in the first layers, we haven't even seen it in the Paleozoic. Everything I just mentioned There are no lobsters, halibut, oysters, sand dollars, mammals, birds, dinosaurs, marine reptiles, whales, seals, flowers, pomegranates, palm trees, figs and dates. Those are biblical things. Or even remnants of grass. We don't start to see any of that until we're getting up into what the young Earth community would call the second half of the flood, where we're starting to see things like fully developed mammals. We see the reptilian body plan adapted for air, pterodactyls. We see dinosaurs starting to appear that are not reptiles, or something more than reptiles, a bunch of them with feathers. We start to see fully adapted for flight, the age of the big dinosaurs, our first flowering plants, marine body plan adapted for water. A little bit later, the mammal body plan adapted for water. We get into the age of giant mammals, Pleistocene, Ice Age mammals, and only in the uppermost sediments do we have things like our primates. All of our grass, like wheat, rye, long grass, it's all in that uppermost set of layers, as well as all the human habitation. Below this, not a single trace of any human habitation. All right. What else might we look at? So that was probably the longest one, and anything else you all mention will be shorter. Yeah, this one just required a little bit of explaining, like what we'd expect to see. So that took a little extra time, but most of the others will be quicker. Yes.
Geologic evidence for the correct ordering, or in terms of the
so is there geologic evidence of the correct ordering for days 1 through 6? The order of appearance of creatures in days 1 through 6 does not match what we see in the geologic record. But at the same time, we have things like plants appearing in Genesis 1 3 days before there's a sun. So there's not an expectation that we're necessarily going to see that one-to-one narrative. So somebody like Hugh Ross, Reasons to Believe, there's a term called concordism, which is not reading Scripture strictly literally, but it is saying that what we read in Scripture that touches on nature is factual, where he would argue that because we're not seeing the alignment in the geologic record of the order of like animal life that's appearing or plants, that it's more of a perspective of somebody that was sitting on the earth. And so like, dark clouds that are covering the sky, and so you don't actually see the sun until day 4, even though it was there in day 1. So, but I find that personally to be trying to make force Scripture into a box that it was not designed for. So that's kind of a long answer to a short question. What are the things we might look for, specifically like testing against competing models?
Carbon dating or like various estimates?
Yeah, so our radioactive dating methods. So one side says radioactive decay rates have been constant through time. We know what those rates are, so we can use them in order to estimate or calculate ages, which gives us some of these ages in millions and billions of years. The counter argument, flood argument, is that they do acknowledge that there is evidence in the Earth's rocks of greater decay, but they argue that that decay rate has not been constant, that it was very fast, say right after sin. Some of them would even say during the creation week, but then certainly accelerated during the flood, so that it just has the appearance of great age. So, all right, so we're gonna look at two things here. First is all right, so here is this, if we take something like uranium that decays into lead. When you look at the sequence of layers, which again, the young Earth community acknowledges that the general order is correct. And everybody agrees, old Earth, young Earth, that you find lots of evidence of decay in the bottom sediments. And as you move up, you see the evidence of less and less decay. So there's a sequence of time that fits that. Conventional model says we can actually use those ratios of, say, uranium to lead to estimate ages that give us these millions and billions of years. Young Earth community, as I said, know that was accelerated radioactive decay. So two things. And you will find some young Earth documents that acknowledge this. Think of a nuclear power plant that goes rogue, right? The two big things that are concerning about a nuclear power plant that gets out of control is the heat and the massive radiation, both which are deadly if you get too close. Well, to get that much radioactive decay in the time span between creation and the flood, you have problems of basically cooking the Earth and having intense radiation poisoning that could well wipe out all life. So somehow that would have to be dealt with at the same time. There's the fine-tuning argument, which I would think that most of you are probably familiar with, but it's the idea that the constants of things like the speed of light, the massive subatomic particles, the force of gravity, are super finely constrained in order to make stars and planets and life possible. So that has led to the idea of the Earth, the universe, being exquisitely fine-tuned, suggesting intentionality, which I think legitimately points to a creator. Doesn't prove a creator, but I think it legitimately points to a creator. Well, that also applies to things like the weak and strong nuclear forces, which dictate the rates of radioactive decay for unstable combinations of protons and neutrons. So if one is to say that in the past we could have had radically different decay rates, that doesn't happen without having very different weak and strong nuclear forces, which means that they are not finely tuned. They could vary quite a bit and everything still works, which means that you cannot logically hold to fine-tuning and to accelerated decay at the same time. You're going to have to pick one or the other if you are going to be logically consistent. Now, so that's in some ways a philosophical approach. So what if we think of it from a more scientific approach? All right. We're going to do that here. This is really cool to me. All right, you see this zipper that runs up the middle of the Atlantic Ocean. All right, what is that? What is it? It is the border between two tectonic plates. So there is actually, as we speak, magma that is moving up into that zipper, and the continents are moving apart. We can actually measure those in real time with satellites. So I'm just waiting for the airline industry to realize that, like, Europe's getting a little farther away from the US every day and tacking on that plate tectonic surcharge. They haven't figured it out so far. So that satellite measurements will come back into play here in a little bit. So actually not just a little bit, right off the bat. So we can bounce signals off satellites. So in the same way that the GPS can track your speed in a car, where it like is keeping track of time and it's keeping track of your location so that it can give you a miles per hour. Well, tectonic plates are a little slower than that. We measure them in centimeters per year, but those satellite measurements for this particular region of the Earth, they're moving apart by about an inch per year, 2.5 centimeters per year. It's about the rate your fingernails grow. All right, so that's how it's done. So now we can measure that distance, and we can look at ages. So here's North America, South America, Africa, Asia, or Europe. And we can date the different zones on opposite sides of that mid-Atlantic ridge. And radiometrically dating, we get about 180 million years for the time when those continents first started moving apart. All right, I'm going to enlarge this. So mid-Atlantic ridge, US, Europe, and Africa. Red is happening right now, like age 0, blue, according to radioactive dating, about 180 million years. That distance, 5,600 kilometers. So when I convert that to centimeters, we are then going to do very complicated math and divide it by the number of years, 180 million years. And if radiometric dating is not dependable, if decay rates have not been constant in the past, we have no expectation whatsoever that rates that we would measure today would be anything like what we would calculate using radiometrically determined ages. What do we get when we divide this? We get 3.1 centimeters per year, which is virtually identical to what's actually being measured in satellites as we speak. What else would you like to see? What else would we consider? How would we test these models? And by the way, all right, so we're already at 12:50. So we haven't gone into a Q&A in large part because we've kind of been doing Q&A for 20 solid minutes here. We could either do another round of this or just kind of open the floor up for more general questions. What do you think? Okay, let's do one more. What else would we look for? Yes. Evidence of water in what sense?
Evidence of a flood. Very pleasant.
Okay. Good.
This could be
Yes. So there's definitely evidence of water on land. I was just looking to see if I have a slide that actually shows. So there's actually an expectation of water on land for both models, because as you have these fluctuating sea levels and fluctuating the continents, there is evidence from the conventional understanding where there's a seaway going right up through the middle of North America, all the way. I mean, connecting the Arctic all the way down to what is today the Gulf, with abundant sea life that's in that seaway. So the question is more, is there evidence of not just that, but of completely covering everything, and in a way that was reflecting the violence of some kind of a cataclysmic event. So we can look at two things. All right, I'll start with this. All right, if I said to you, I have a baked good that is a mixture of icing and cake, which one would that be? That's both, right? On the one on the left, I've got an item that is a mixture of icing and frosting, but it's very orderly, right? It's in a layer where it's either just cake or just frosting, right? But if I added that, hey, this was produced in a chaotic manner, a cataclysmic manner, now what's our expectation of what that mixture should look like? Yeah, it should look like what we find on the right. Well, there are claims that you can go around the world and find mixtures. And by the way, the conventional model doesn't say you'll never have mixtures, because you can get a local tsunami, tosses marine creatures up on land. You can get a regional flood that washes terrestrial creatures out into a bay and they get buried. And we have examples of those. But our expectation is that that would be much less frequent, and the norm would be just all terrestrial or all marine. Well, you can go to places like the Grand Canyon where there is this Temple Butte formation where the formation has both terrestrial and marine fossils in it. But if you look at it closer, even though it has a single name, you can see that this is an ancient river channel carved into the underlying limestone. The bottom set layers contain terrestrial river environment creatures. Then it transitions to be marine creatures consistent with rising sea levels and flooding of that river valley. So even though the formation has both, the sublayers are just terrestrial or just marine. And that's what we see over the entire planet, that the vast majority of these layers are not chaotic mixtures. And in fact, they're often intact ecosystems that have not been ripped up. They're just buried in place. And I'll just on this one as well, that you'll also see some slides like this, where you see fish together with a bird, insects as evidence of a mixed chaotic system. But in almost every one of these occasions, what we're looking at are inland freshwater lakes, where they're freshwater fish, and they're creatures that are typically found in a lake environment. You know, a bird flies over, something happens, it gets sick, it falls in the water, gets buried. It's not marine. And it's not chaotic. We have very well-established layers that are consistent with ancient lake deposits. One last thing. This is cool. And then I know we're running out of time here. So what if we had creatures that we expect to live in the same environments, in the same ecological niches? So here's marine reptiles. They're air breathers. They're mostly carnivores. They live in ocean environments, open ocean. So there's an expectation that we would find these well mixed with marine mammals, which are also air breathers, mostly carnivorous, many open water environments adapted. So in a flood model, we'd expect these to be well mixed, or at least in alternating layers, whereas in the conventional model, recall that expected progression, because reptilian body plans would be expected to come along first. We'd expect to find those, the first appearance of the marine reptiles, earlier than first appearance of marine mammals. So where do we see them? Oh, we could say the same thing about birds, but for time, I'm going to skip those. So just sticking with the marine reptiles and mammals, that's where we find the marine reptiles. That's where we find the marine mammals. Not only are they the first appearance separated, their entire existence is separated in time. And it's also fascinating to me that we only find the marine mammals in layers that the flood geology community identifies as being post-flood.